First example, looking at the review for chapter 3, we're asked to figure out which functions are used to solve this by graphing. So one thing I could do two separate, make this y1 and make this y2. But here I notice the answers are just as one function alone by itself. So that probably lets me know, since they're just using one, they're probably setting one side equal to 0. So if I subtract that, I look for an x cubed into minus x squared, minus 2x squared, which is maybe right here, and then I would have a negative x, and then if I add 2 to both sides, that'd be set equal to 0. So it might be that way, or I could have subtracted x cubed on this side and moved it over here and then added x. So look for, it also could be all negative, like if the answer was, say, negative x cubed plus 2x squared plus x minus 2, that just means this side got moved over here when it was set equal to 0. Okay, so this is the answer there. Now as we move forward on this next one, we can see that we're looking for this graph. It's shown right here, and this one just asks how many solutions, has how many real solutions. So just count the x-intercepts, 1, 2, 3, 4. So I can just say 4 real solutions. It might ask you what are they, so then I look to see where they cross. So this one looks like it crossed at -2. This one's between -1 and 0. This one's between, this one right here is between 0 and 1, and this one is between 1 and 2. So it might ask that, what are the actual zeros, or it might ask how many solutions do you have. Okay, so there's that one. This next one, use a graphing calculator, and again we could do y1 and this is y2, and then see where they intersect each other, and we could do that, or we could again set it equal to 0 and see where the x-intercepts are. So you just either graph both of those or set it equal to 0 and graph and see where the x-intercepts are. But if you check this in your graphing calculator, you get -3, you get 0, and you get +3. Okay, and then this next one, you will have a problem like this. So you have a one box with a 3 by 4 by 2, and it's a box. Mine's probably not the greatest box. I don't know if that looks like, there you go. I guess that's a jewelry box. So that area right there would be 24, right? Length times width times height, or the volume of it. And then it says we're going to increase this box. We're going to have the same box, but then we're going to increase it a little bit more. That probably looks terrible, but sure. Increase it by x. So that would be 3 plus x. That would be 2 plus x, and that would be 4 plus x. And it says this new volume is equal to double this. So whatever this is, it's going to equal 48. And so you get, let me see here. Okay, so if you multiply these two together right here, you get x squared plus 5x plus 6. Then I got to times by this one because I'm finding volume. So I distribute the 4, then I distribute the x, and then I combine like terms here. So I get an x cubed of plus 9x squared plus 26x plus 24. So here I could do that as y1, I could do this as y2 and see where they intersect, or I could subtract 48 on both sides, see where they intersect each other. Right, so I'm going to see where they intersect each other, and then I'm going to look at this equation and see either where it crosses the x-intercept if I set this equal to 0, or if I do 2, I want to see that where they intercept at, and it should be approximately, and I think this one you had to pretty much do 2 different ones. So I think you have to put this as y1 and this as y2, and then make sure y2, and then make sure your window is probably like a 0 to 10, or you can do 0 to 5. But here, if I put it as 2 equations, I want my top to be probably like somewhere around 50, right? Because if I want 48, then I probably want to be 50. So somewhere in there, so maybe 0 to 50, count by 5s or count by 10s, and then look where they intersect each other. All right, this next one, select all answers that apply. So here we can just, again, y1, y2, or set it equal to 0, and put it in there, see where they intersect each other, or if you set it equal to 0, look for those x-intercepts. And so that answer is -1, 0, and 9. Okay. Next one. Okay, this solving by proving. So basically this one is you're just solving this, and you're writing which steps you did in order to get there. Okay, so to solve this, it's by grouping, right? So I want to put these two together, x cubed plus 4x, and I want to say, what is the greatest common factor between x cubed and 4x squared? Make sure I get that right. Well, I can take out a 4x, or an x squared, right? Because they both have an x. So an x squared, that leaves me with x plus 4. Now, when I group these two together, this negative 4x minus 16, I know I'm going to get in my parentheses an x plus 4. So what times x, the negative 4x? That would be a negative 4. Now those parentheses are the same, because if I distribute this, when I get to this right here, negative 4x minus 16, so I know I did it correctly. Okay, now if I look at both these parentheses, I can see that they're the same, so I want to factor those on the outside. And so I get an x plus 4 on the outside, factor that out, and I get left with an x squared, my greatest common factor, the first one, minus 4, my greatest common factor, the second one. Now I can factor this even more because it's a difference of 2 squares. I can rewrite 4 as 2 squared, so it is x minus 2, x plus 2. And now it's down to my prime factors. And now that it's down to my prime factors, I can go ahead and solve, set these both equal to 0, or all three of them equal to 0. X plus 2 equals 0, and get x equals negative 4, x equals 2, and x equals negative 2. So then I'm just looking for these steps, right? So I went factor out the greatest common factor, so it should look like that. So that one looks like right here. Okay, then I went and factored out that parenthesis. So it looks like, and it's a negative, right? A negative 4 right there. So there, this one is negative, or this one's positive, this one's negative, so there's the next one. And then here I factored it to all three of them, right? So I look for that. Looks like a plus 2, a negative 2, and a plus 4, and that's what I have. So this one goes to number 3, and the last one I have my solutions, which is negative 2, positive 2, and negative 4. So this one's number 4, or I could number these. This is 1, this one was 2, this one was 3, and this was 4. So you can do it either way. Draw arrows. Make sure your arrows are distinguished. Mine don't look too good, so maybe number it like that. Okay, number 7 here. Find all solutions, select all that, apply. So I can see this quadratic form because this is double, or 4 is double 2, so I can use as a quadratic. Instead of solving, I'm going to solve for, instead of x, I'm going to solve for x squared. So negative b, that'd be a positive 1, plus or minus the square root of b, the square root of b squared, so b squared is just 1 again, minus 4 times a times c. So that would be 8, 9, all over 2a, so that's 2. And so this is negative 4 times negative 2 is a positive 8. 8 plus 1 is 9, so I have 1 plus or minus square root of 9, which I know is 3. So it's 1 plus or minus 3 over 2. So I got to do 1 plus 3 over 2, which is 4 over 2, which is 2. And then 1 minus 3, which is negative 2 over 2, which is negative 1. So those are my two answers, 2 and negative 1. But it is equal to x squared, right? Not x, because we're in quadratic form. It's always that middle term, what's it's equal to. So now I got to square root both of these. So I get an plus or minus I, and then a plus or minus root 2 are all 4 of my answers. And I know that's 4 answers because it's a quartic there. So plus or minus root 2 and then plus or minus I are my solutions. So then I move down to this next one. I got area problem. Say these areas are equal, right? So that means if I just take these two, multiply them, and I get x squared plus 4x. And I set it equal to the area of this one, which is, 2x squared minus 4x, so minus 1x, and then minus 6. Right, I'm just flowing those out there. Now I can either do y1 and y2 and see where they intersect, or I could set it equal to one side and see where my x-intercepts are, right? And I get my answer as, you might have a negative and positive, and since we're talking about area, you want a positive area. So if you get a negative answer and a positive answer, when you solve it, when you find your intercepts, take the positive because we're talking about distance. So that distance is 6. Okay. Looking at number 9, we want to make this left-hand side equal this right-hand side. So we can see that we can start with the original one. So this is the original one, and we can see what they did. So here we could FOIL that out, and that means that there's 3 of them. So we can see that, hey, there's 3 of them right there. So that looks like that one. Then we can go ahead and FOIL those ones out. We get x squared, so this is number 2. Get an x squared plus xy plus 2xy. There's really 2 of them in there. And then plus y squared times this. So that one is this one right here. And then if we FOIL that out, we get 8x cubed plus 2x squared y plus xy squared. Distribute the y now, and we get a plus x squared y plus 2xy squared, and then plus y cubed. Then we could look for that one. They might combine like terms first on that one. So here we get an xy squared and an x. I don't think they have that one in there. Maybe they do. 2, a 2. Yeah, right there. Okay, so that's number 3. Okay, and then they combine like terms, and so they get a 3x y squared. They can combine these, so they get a 3x squared y, and then a plus y cubed and a plus x cubed, which is right underneath that, right there. Then I can place the x cubed and the y cubed together, x cubed and the y cubed together, and then I can factor out of these two a 3x and a y, and so I get left with a y plus x, like that, and that is my right hand side. So that is that one right there. So that's number 4 right there. I guess that's not number 4, that's actually number 5, I think. This was actually 3, is that one? Then combine like terms is, that is 4. And then, let's see, then I move them around, so this was 5. Since I moved them around, that's 5. And let's see, and then this one is 6. Factored that out, so then it looks the same. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6. Oh, I guess, sorry, my order is a little mistaken there. The original was 1. 2 was this one. 3 was this one. Right, had the factors right there. 4 was rewriting them into, 4 was this one, then 5, then 6, getting the 3's together and x cubes out front, and y cubed out front, and then factoring out the 3x was 7. So there you go. You got to kind of do it yourself. Make one side look like the other, and then match which one each step. So that one's a little time consuming there. Okay, number 10 might be a little easier because it kind of gives you the steps for you, which each step are, and you're proving again. So you're saying, okay, how did I go from the left-hand side? So how did I go from this one? So what's this one right there? And that is my original, right? So the original one goes there, original. Then how did I go from step 1 to step 2? So there it looks like this is foiled out. So that's a sum of a square. And then how do we go from step 2 to step 3? So there it looks like this one is foiled out. So a difference, square of a difference. And then how do we go from step 3 to step 4? It looks like things are kind of just rearranged, right? You got an x squared and a negative x squared. So those are kind of just rearranged. So that is commutative property. Commutative property. And then how do we go from this one? This one looks like we just combine like terms. Okay, so that's how you do the first 10 problems.